Hello and welcome to this presentation. In this session, we will talk about the Oracle MySQL database service with the HeatWave extension for real-time analytics. This is the second part of my MySQL Cloud service presentation. The earlier one was about the MySQL core database service. In this presentation now, we will talk about the so-called HeatWave extension to the MySQL database service for analytical workloads. My name is Carsten Thalheimer. I'm located in Frankfurt. I'm a so-called solution engineer. I'm working for the MySQL GPU since a couple of years, and especially since last year, I'm spending most of my time with the MySQL database service and with the HeatWave extension as well. Before we start, I need to start with a rather boring logistical slide. Sorry for this. Again, I'm sorry for this slide. It's a boring one, I know, but Oracle is a US-driven company. It's listed on the NASDAQ, and therefore I need to make sure that this safe harbor slide is included. And the following content of my presentation is an outline of our product direction. In case that I talk about upcoming features, which I probably will not do, this is not a commitment. It probably shows our plans and our strategies, but we can change it at our discretion at any time. Or in other words, I can be completely wrong here, but of course I'm trying to be as accurate as possible with everything what I'm going to demonstrate and what I'm going to say. As said early on, I'm working for the Oracle MySQL GPU since a couple of years. In fact, I was acquired as part of the Sun Microsystems acquisition in 2010. You probably know that Oracle has a huge product portfolio. We're probably talking about a couple of thousand of products. I don't know the exact number, but let's face it, it's huge. The MySQL product hasn't been very visible on the top management level or at the level of Larry Ellison. Or at least I don't remember a significant statement regarding MySQL in the earnings calls in the last 10 years or something. The interesting thing is that this has changed. Beginning of December 2020 last year, during the earnings calls, Larry Ellison talked, in fact, a lot about the MySQL database service and the MySQL HeatWave technology. This gives you a bit of insight on how important the MySQL is these days in Oracle. A lot of Oracle colleagues suddenly speak to us and they want to get in contact with us, what this HeatWave technology and what this database technology is. So it's quite exciting times in Oracle when you work for MySQL. Before we dive into the HeatWave technology, a short reminder, what is MySQL and where's the problem? Is there a problem? So MySQL is mainly a relational database. Let's face it, it is transactional, it is ACID compliant, MBCC, multi-version concurrency control. It's based on an ARIAS theorem from the 1970s or so, but it's mainly about OLTP, online transaction processing. It's all about low latency and high throughput. InnoDB supports encryption, it supports compression, and we do have InnoDB cluster, but probably that's something which you know already. And let's face it as well, a typical MySQL database is probably in the area of 3-digit gigabytes. I know that some customers have, in fact, far bigger databases in the area of a couple of terabytes, and some customers probably have much smaller databases in the area of a couple of single gigabytes, probably. But, well, let's face it, so a lot of customers are in this region. The theoretical limit on the other side is in the area of 64 terabytes with the default settings. So on my last slide, we talked about OLTP, but what about OLAP, right? So first of all, MySQL supports a lot of data. We talked about 64 terabytes on the other slide, right? So that's a lot of data already, I would say. Now, we also support common table expression. We do support window functions since MySQL 8. And we've got a lot of nice things which makes your life a bit easier when you're using big data and when you're doing those OLAP. Well, let's face it, there is no simple solution for SQL analytical queries, right? You can always tune the MySQL database. It's probably getting a bit bigger, but let's face it, your data is growing as well, which means that your problem over time is getting worse. Index is always a good thing, right? In case that you use an index is a fantastic thing. But then again, right, there are limits here. And the same with better or faster hardware. More memory is always a good idea to have, but let's face it, there are limits. And in case that you reduce the cardinality, that's what a lot of customers are doing as well, you probably have even a temporary solution only because, again, databases usually are getting bigger these days. So very often customers, in fact, they are looking at other database technologies for this particular problem of the analytical queries. So a lot of customers, in fact, are running the analytical workload outside of the MySQL database because MySQL is not designed for OLAP-based queries, but has a very strong focus on OLTP. So from an architecture perspective, that's probably the picture where you end up. So you've got on the one side your application, which are basically writing to the data, so OLTP based load, so mainly writes probably, and you probably write it to the MySQL instance. On the other side, you probably have maybe the same application or different application, which are doing reporting or analytics, but they probably do connect to another database. Now the question is, how do you get the data from the MySQL environment to the other database? Well, this process is called ETL. But why is ETL? Why is it a problem, right? So first of all, there is the extraction process, right? You need to extract the data from a MySQL perspective, which means that you're probably heating up the MySQL environment because you're probably reading a lot of data from the environment. So that's the first thing, right? You need to load the data from a MySQL environment. And then probably the even bigger problem is that you need to move the data from the MySQL environment to the other environment. Well, and things like security are probably getting a key problem here, right? Because you have to send the data from one instance probably to another. Probably you have to send it from an on-premise version to the cloud, probably a complete other cloud. Now, and of course, right, you've got the challenge of having now multiple databases to manage, right? It's great that those databases are doing a fantastic job for the particular workload, but then again, let's face it, right? You end up probably with twice the cost, with twice the knowledge, with twice the environment, and so on and so forth. And another big issue is that this whole process of extracting the data and moving the data takes a bit of time, which means that basically you can't really support real-time analytics, right? So data which is recently added to the MySQL environment in this case is probably not immediately available on the other system, which probably means that your analytics is probably not as accurate as you want it to be. So in the last couple of slides, we talked about the OLTP and OLAP problem. And this is basically the story to the development of the HeatWave technology from the Oracle labs. HeatWave is an in-memory query accelerator for the Oracle MySQL database service for speeding up analytical queries as well as long-running complex OLTP queries. This is all done in the context of a single database, which is the MySQL database service. All existing MySQL applications or MySQL compatible application will continue to work as is. There is no change needed. It provides a single unified platform for OLTP and for OLAP workloads. So going a bit more into detail about the architecture and what I just said on the last slide. So again, it's a single MySQL database for both OLTP and OLAP analytic-based queries. When you look at this picture, right, you can see that the OLTP applications and the OLAP applications are basically addressing one single instance, the MySQL leading node instance. That is a normal MySQL 8.0. something version, right? And in the backend, we've got the so-called analytics engine, which are own instances which are directly connected to the MySQL leading node, to the OLTP front-end engine. All existing applications will work without any changes. It's basically MySQL, right? There is no change. We're going into more detail in this with this in a second. And this enables also the analytics for an on-premise version of MySQL, because you can replicate your on-premise MySQL data to the Oracle Cloud, and you can, based on this replica server in the cloud, you can add the HeatWave extension as well. And this adds extreme performance. It accelerates the queries by orders of magnitude. Later on, we will compare MySQL versus normal, MySQL HeatWave versus normal MySQL, and we will always bring up the number of 400. So it's about 400 times faster. From a pricing perspective, it starts at about $840. Again, we will go into more detail here. And this means that this is the price for a MySQL leading node, as well as for 2 MySQL backend nodes. So each MySQL backend node, MySQL HeatWave backend node, can address about 400 to 500 gigabytes of data. So how does the MySQL HeatWave technology, how does it work from a MySQL perspective, right? So first of all, the parser is unaltered, which means that all the existing applications will continue to work with the normal MySQL product, right? There is not really a significant change here. So this box, which you will see here, that is the box which you will see here, that's normally a normal MySQL database service. Now, when you go to the MySQL Cloud, when you go to the Oracle Cloud, you will see that there are 2 shapes available. There is the normal MySQL database service shape, and there is a special shape which is called MySQL database service for HeatWave. We need the MySQL database for HeatWave. The main difference is that the HeatWave instance has an extra component, an extra engine, which is called Rapid. This Rapid engine is needed for the HeatWave technology. Rapid is the internal code name of the development of the HeatWave technology. So what Rapid basically does is it connects to backend services, the so-called HeatWave node. Those are running in the back. Those HeatWave nodes are usually only connected to the MySQL service. This MySQL service, given that's the kind of the front end node to the application server, it's called the MySQL leading node. So the Rapid node, the secondary engine, is basically connecting to 1 or 2 more MySQL HeatWave backend services. When you load the data from a MySQL application perspective, again, right, I already said that the parser is unaltered. And basically what happens is that you store the data in your normal InnoDB table. So in this case, let's assume that this is a small table which we are storing on the old traditional InnoDB way. No change here. The change jumps in when the optimizer recognizes that the table which you selected has a secondary engine option for the Rapid, which basically means that we are sending the data also to the HeatWave backend services. So the data, in fact, is persisted on the InnoDB level, no change here, but we have a copy of the data which we send to the HeatWave backend services. And in fact, we do not just load the table, we also transform the data. So based on the table itself, you can specify which databases, which tables will be loaded or should be loaded to the HeatWave technology. And in addition, the data itself is transformed. It's not longer stored in rows anymore. It's stored in a columnar way, and it's stored in memory only. It's vectorized and it's distributed across various backend services, which means that your table on the HeatWave environment, for example, can look like this. So in this case, the user decided that the state, for example, is not relevant for any analytical query. So therefore, right, he's only updating or just sending some fractions of the original data to the MySQL Analytics backend, right? That's optional, right? You can configure this behavior. So once you run a query from your application perspective, again, the query is executed on the normal MySQL. The MySQL is always the front-end system to your application server. That's the reason why we're calling it the leading node. Now, the optimizer recognizes that there is a cost attached to this query. And the optimizer can, based on a threshold, specify that this query should not be executed on the normal InnoDB product anymore, but in fact, the query should be pushed down to the HeatWave backends. And the HeatWave backends, because they are in memory and because they are vectorized and in columnar, are probably executing the query significantly faster than the normal InnoDB one. So the HeatWave backends are replying back to the MySQL server, and the MySQL server is replying on behalf of the HeatWave backend to the application. Again, the front-end system from an application perspective is always the MySQL database, always the MySQL leading node. And that's the idea of the HeatWave technology. Now, I said in memory, right? In case that you're running out of memory, one instance of MySQL HeatWave can address about 400 to 500 gigabytes of data. You can add as many servers as you want to. I think officially we say 16 at the moment, but on the next slide, you will see that we probably can address even more. So this is the basic technology behind HeatWave. So you start with normally 3 servers. You've got the so-called MySQL leading node, and you've got at least 2 HeatWave backend nodes. And in case that you specify an extra attribute, a secondary engine to a table or to a database, you can basically push the data not just to InnoDB, but you can also copy the data to your HeatWave backend services. And in case that there is a query which is more expensive than a certain threshold, this query can be executed in the HeatWave backend nodes and not just on InnoDB. The other way around, in case that it is a really cheap query, still the InnoDB is responsible for the SQL things as usual, right? You can still execute your queries either on InnoDB or on the HeatWave, and you can even force a query to be executed on this or on that environment. Well, I already talked about the HeatWave backend nodes, and keep in mind that each HeatWave backend node, at least today, has about 16 OCPUs. We start with a minimum of 2 nodes, which means that we do have about 32 OCPUs, meaning 32 cores for the HeatWave backend node. But it's quite interesting to see that on a benchmark, the Oracle team provided numbers where we can show that we are really, really good at scalability. So when you add a couple of more instances in the background, you can see that we are still far above 90% of the expected linear scalability, which is really, really good and a good design or a good sign for really good architecture. We are doing this whole HeatWave technology for one reason, to speed up analytical queries. That's the main reason for the HeatWave technology. In this picture, we are comparing the performance of MySQL InnoDB versus MySQL HeatWave technology. In this picture, or in this benchmark, we came up with a speed up of about 400 times. That's probably something which you will see in your own benchmark in case that you're running an own benchmark as well. Now, we talked about the numbers, we talked about scalability, and we talked about database size already. Let's go back to the pricing, right? So early on, we talked about the problem of OLTP and OLAP, and I said, well, probably customers are switching to another database technology. The interesting thing is that this is not really cheap here, right? When you look at our competition and what they are offering here, right, it's getting really a bit expensive here. So what is the price tag of HeatWave and how is it calculated? So in the previous slides, I already said, right, there is a so-called leading node, and you can only have one leading node today from a MySQL database perspective. And this is the MySQL database for HeatWave standard E3 leading node. This is a 16 CPU instance with 512 gigabytes of memory, and there is a fixed price for this one, which is $263. And each of the backend nodes, and keep in mind that each of the backend nodes can cover about 400 to 500 gigabytes of data. It's the same shape. Again, it's 16 OCPUs and it's about 512 gigabytes of memory, and it has the same price tag. Again, $263. But in the architecture slide, I said that you have to have at least 2 instances. And this is in fact the kind of the smallest possible instance. And when you add a bit of storage here, so I added a terabyte for the block storage, for the persistent storage of the data, for the leading node, right, you end up at about $830. So this is kind of the minimum environment what you need from HeatWave. You need 1 leading node instance, you need 2 HeatWave backend services, and about 1 terabyte of storage, which leads up to $829. So we talked about the MySQL database HeatWave, and we talked about a couple of slides and what's going on under the hood. Let's do a demo now. Let's see how MySQL HeatWave really works and what is the speed improvement. So I am in the Oracle Cloud infrastructure now, and I'm in the MySQL section. So I would like to set up a new HeatWave environment. So first thing what I need to do is I need to provide a new MySQL leading node. Let's call this the MySQL leading node. And description, this is just a test system, right? Normally you would select a standalone or a high availability cluster. Well, in our case now, we need to configure the so-called HeatWave environment. Username, password, that's rather clear. And in my case, right, it should be executed on my virtual cloud network infrastructure 82. That's fine for me. I do not want to prefer a special fault domain or something else. And as you can see, there's only one shape which is available, which is the MySQL HeatWave shape. And keep in mind, it's 16 CPUs and 512 gigabytes of memory. I'm not really interested in any backups here, but I would like to configure this server so that it has a name tag, and it has a name tag of CTHW. And all the rest, I leave it basically as it is. And that's it already. That is the setup of the leading node. The leading node is deployed now. It is available. So the next thing after the deployment of the leading node is that you probably need to deploy the HeatWave backend services. And again, this is rather straightforward. You go to the MySQL leading node, and you go to the section of the HeatWave instances. At the moment, the HeatWave instances are disabled, and I just add the HeatWave instances, and I just select, I leave everything as a default, right? And in fact, I cannot even change the shape here. It's 16 CPU, and it's 512 gigabytes of memory. And you cannot go with one. You have to have at least two or more. In case that there is an existing database running, you can use this tool to make a prediction about how much data you need. I know that I do not need more than 400 or 500 gigabytes. So in fact, this system is even too big. So I'll leave everything as it is. And I just press the add HeatWave cluster installations. And again, this probably takes another 5 to 10 minutes, and the complete HeatWave cluster is rolled out. So again, my two HeatWave nodes are deployed now as well, which means that my whole HeatWave cluster is up and running. That's probably a good time now to do the configuration and to go to the configuration of my MySQL Workbench. In my case, I will use the MySQL Workbench from my home. Again, I'm located in the area of Frankfurt, and I will connect to the MySQL database, to the MySQL HeatWave instances with MySQL Workbench. So let's have a look at the configuration of my MySQL HeatWave, right? In fact, I'm using the standard TCP over SSH connectivity, which means that first of all, I'm connecting via SSH to my host, which is ending on 182. And from this host, furthermore, I do a jump to my HeatWave, to the MySQL leading node environment, which is the system called CTHW. And when I connect to this instance, you can probably already see that I created a small TPCH benchmark. This is about 10 gigabytes. In fact, it's a bit bigger. It's about 12 to 13 gigabytes of data. And this is what we are going to use for our benchmark here. So let's go to some of my prepared statements. So we are using TPCH 10, the TPCH 10 database, which is about 10 gigabytes. Let's have a bit of insight into the database, right? We are concentrating on two databases. We are concentrating on the nations database, and we are concentrating on the line item database. The nations database is a small one. The line items database is a big one. Overall, the TPCH database is in the area of about 13 gigabytes, as you can see here, right? Let's run some commands, right? Let's do a select count from TPCH 10. So TPCH 10 has about 25 records, right? A very small database, in fact. I can, with select star, easily see what's in the comments here, right? And what's in the database, very small. The cost of this query, select star from TPCH 10, is rather cheap, 2 dot something, right? Because it's a small database. And when I do the explain, right, there's nothing spectacular here. Have a look, have a focus on the extra database. So let's do the same with the line item database. And as you can see, the line item database is significantly bigger. It has about 60 million records. So it's about 10 gigabytes or something. The majority of the database is in fact the line item database. And let's do the same again, right? Let's do a select star and let's limit it by 10. And let's have a look at the last query cost. The last query cost was in the area of about 60 million or so. 6 million or something. So it's still fast, right? And keep in mind, this is a quite beefy server here, so it's quite powerful. So but still the cost is in the area of 6 million. And when you do the explain, right, again, have a focus here on the extra field. You will probably recognize that there's nothing spectacular going on. It's still a normal InnoDB system. So even though when the rapid status is online, given that when you are double checking the performance schema, no table is loaded on HeatWave, it's the normal InnoDB behavior. Nothing has really changed here. So with this normal InnoDB behavior, right, let's run the query number 1 from TPCH benchmark. That's the query which I just copied from GitHub, right? Well, in case that you're interested in it, do it as well, right? And I will execute this query. And it takes about 130, probably 130 something seconds. So therefore, I will run this query. I will stop this video for a second, and I will come back in about 2 minutes from now on. So let me execute the query, right? Oops, sorry. Let me execute the query. And as you can see, the query is running, and I'm coming back to you in a second. So the second took about 2 minutes. And as you can see, the query was executed in about 125 seconds, which in fact is a bit faster than expected, but nevertheless, it took more than 2 minutes to execute this query number 1 from the TCPH benchmark. So let's do the same, but let's do the same now with the HeatWave technology. Now, to use the HeatWave technology, the first thing what you need to do is you need to add a secondary engine, and we are adding a secondary engine to the nations table, and we are adding a secondary engine as well to the line item table. Again, this is rather simple, and this is a rather fast process, right? Now, when we do the secondary load to the table, it basically means that we are loading the table from InnoDB and we are loading the table into HeatWave. Now, for the small table, for the nation table, that was rather quick, that's clear. But have a look how long it takes for loading the table from the line item table. So the line item table is in the area of about 10 gigabytes. And we usually load about a gigabyte or something per second. So in about 9 to 10 seconds, 8.4 seconds, it was at the end, right? The table was loaded. So this means that we've got the nations table and we've got the line item table now in the HeatWave technology. Let's validate it. So first of all, right, the rapid service status, it is still online. That's kind of expected. Let's use the performance table. And as you can see, the table line item and the line item and the table nations, they are both residing on the HeatWave cluster now. So we are doing the same story again as before, right? Let's do a select star from the nations table because it is a very cheap query, right? And when you look at the explain, nothing has really changed here. Because it's a cheap query, it will be executed on InnoDB. Let's do the same with the line item table. Let's do the limit by 10. Keep in mind that the query was far more expensive. So the query took about 6 million or something, which means that this query, in fact, will be executed not on the local InnoDB engine, but on the rapid engine. So the HeatWave cluster itself does work. And now let's do this test again. Let's run the query again, the query number 1 from my TPCH benchmark. And you remember it took about 125 seconds before to run it. Let's have a look how long the query will run. So I'm executing it now. The query took about 0.7 seconds. When you do this query from time to time, 0.7 is probably even a bit slow. When I'm doing the query again, it's in the area of 0.4. Probably there was a hiccup or something else. So just to be clear here, so executing the same query with the same result set on the same environment with the same query on HeatWave took about 0.4 seconds. And the same query on InnoDB takes about 125 seconds. When you go to those TPCH queries, the query number 1 is even not the worst query. There are more worse queries than the query number 1. But even here, you will see a speed up 0.4 versus 125 seconds in the area of 300 to 350 times faster. The more data you have, the more likely you will not run it out of the InnoDB buffer anymore. And in fact, the difference between the speedup will be even higher there. So that is the cool thing with the HeatWave technology. So even on a normal InnoDB system, queries are significantly faster executed. And this opens a complete new market, a complete new use case for the MySQL and for the MySQL HeatWave technology. So this was just a small demo. I invite you to do the same in case that you need any help, right? Give us a call, give my colleagues a call, give myself a call, and you can run the same test here. And let's switch back to the slides now. So this was really just a small test about one single query. When you extend the test to more queries, TPCH has about 24 queries, then you will get even more insight. And again, right, so query 1 wasn't the worst query. There are more worse query than the query number 1. So this is based on the statistics which I did a couple of months ago. The new version is even quicker, and the speed up between InnoDB and HeatWave is probably even higher here. But then again, right, InnoDB, that's something which you will see as well, is getting even faster. So give it your own test, give it your own try, and probably do not want to test artificial data. You probably want to test your own data. And we really invite you to run your own data and your own test. And therefore, in case that you're interested in running a trial in the Oracle Cloud, feel free to ask us to either go to cloudoracle.com or ask us for a $500 promotion. So we invite you to test the MySQL database service and the MySQL HeatWave technology. And after the 30 days, after the $300 or $500 are spent, you can still use the Oracle Cloud. You get an always free account, which basically means you can run a couple of instances, compute instances or database instances as well. The nice thing with the $500 promotion, by the way, is that there is no credit card information, so it's even simpler. Just ask us, send us an email, or get in contact with the Oracle colleagues of mine or with myself, and we will organize this for you. I'm coming to the end now. Thank you very much for attending. I hope you enjoyed it, and I hope you learned a bit about the MySQL database service and the HeatWave technology. Have a great remaining day. Have a great remaining Percona life, and hopefully see you soon after this whole COVID Corona disaster. Would be really great to meet you in person soon. Thank you very much. Bye-bye.